Paul and Patricia Churchland are two Canadian philosophers who are married to each other, and they have devoted most of their professional lives to exploring the implications that the study of the brain has for our understanding of the mind, as well as for illuminating traditional philosophical subjects such as knowledge, free will, and morality, among many others. In 1990, in the same number of Scientific American that contained the article by Searle that we discussed in our last video, they published a now famous reply to the Chinese room argument. In that article, Churchlands complain that the Chinese room argument fails to provide a decisive case against a strong AI program. And the reason is that premise 3 is question-begging. A statement intended to prove something is question-begging when it itself assumes what is intended to prove, making the whole case viciously circular. If you remember, Searle's third premise is that syntax by itself is neither constitutive of nor sufficient for semantics. Also recalls that premise 3 is supposed to be supported by the Chinese room thought experiment. You're supposed to agree that, although Searle is keeping track of the syntax of the tokens, he is completely unaware of their contents. So what Searle is doing here is eliciting your intuition that his token manipulation is going on in semantic darkness, so to speak. However, the Churchlands object that whether syntax is enough or not for semantics is to be decided by carrying out an empirical research program, not by consulting our common sense intuition. They warn us that our intuitions about unknown or controversial matters may be unreliable, and they may be the result of ignorance or prejudice rather than genuine insight. They illustrate such unreliability by means of a scenario that they call the Luminous Room, which is intended to be analogous in all relevant points to Searle's Chinese room. You may remember that in the mid-19th century, James Clerk Maxwell showed that light was just one of many possible types of electromagnetic radiation, and he devised a series of equations describing the relationships between electric fields and magnetic fields. In particular, these equations relate the rate of change of one field, electric or magnetic, to the other. And you can use them to describe how electric and magnetic fields are generated. Okay, so consider Maxwell's claim that light is an electromagnetic phenomenon. Suppose some follower of Maxwell back in the 1870s proposed a theory of artificial luminance, or AL, that says that you can obtain genuine light through the manipulation of electromagnetic waves. So it would be strong AL. Also, assume that someone, say Searle's great-grandfather, back then proposed an argument like the following to refute artificial luminance. Premise 1, electricity and magnetism are forces. Premise 2, the essential property of light is luminance. Premise 3, forces by themselves are neither constitutive nor sufficient for luminance. Conclusion, electricity and magnetism are neither constitutive of nor sufficient for luminance. So here you have the arguments side by side, right? So again, they're meant to be completely analogous. So if you think that there is something wrong with one, then you should also think that there is something wrong with the other. Okay. Furthermore, the critic defends premise 3 by means of a thought experiment known as the Luminous Room. Again, just like Searle defended his own premise 3 by means of the Chinese room. Remember that premise 3 is that forces by themselves are neither constitutive nor sufficient for luminance. So, well, here we have, this is the Luminous Room. Okay, consider a dark room containing a man holding a bar, magnet, or a charged object. So, if artificial luminance were true, this would initiate a spreading circle of electromagnetic waves, and thus the room would be luminous. So, let us put ourselves in that room. Right? See, we start swinging that magnet. Now, is there any luminance? Okay, well, picture yourself in that situation, swinging that magnet up and down. What happens? Well, it looks like the room remains as dark as ever. So the Searle's relative says, well, no way, no luminance. You might add, well, it is inconceivable that you might constitute real luminance just by moving things around. So it seems like electromagnetic forces, or any other forces for the matter, Even when set in motion, well, they produce no luminance at all. But is the critic of strong artificial luminance right? Surely he must be wrong, since we know that oscillating electromagnetic forces do constitute light. Well, part of the inadequacy of the scenario is that the man in the room cannot oscillate the magnet fast enough, so that the resulting electromagnetic waves are too long to be in the visible spectrum. Also, their intensity is too weak for human retinas to respond to them. But where the critic went wrong, according to the Churchlands, is in using his intuition to decide what surely was an empirical matter, right? But this, according to the Churchlands, exactly mirrors the mistake made by Searle, who is using his intuition in a strange counterfactual situation, right? A kind of situation where intuition is notoriously unreliable to decide a scientific question. So here the conclusion is that such questions are to be decided in light of the empirical success of the research program based on the hypothesis at issue, and not by intuition pumps. They themselves don't use this term, intuition pump, which is due to Dennett, but I think it fits well here. It's in the spirit of their proposal. So what they say is, well, just let strong AI run its course. And if it succeeds, then the claim that you can get semantics out of syntax will be vindicated. And if it fails, then, well, the claim will be weakened. So this is their criticism. Now, although the Churchlands think that the Chinese room argument is a bad argument, that doesn't mean that they are fans of classical AI. In fact, they're not. They do accept a sort of computationalism about the mind, but not of the sort we've been discussing so far. Indeed, they think that claiming that the brain is a computer does not entail most of the characteristics associated with classical architectures, right? They don't entail that they're serial digital computers, or that they're programmed, or that they exhibit the same software-hardware distinctions, or that they are symbol manipulators. Rather, they prefer to model brain computation by means of neural nets, in which processing is parallel and representations are distributed, and you have associations among units rather than explicit rules, and they're trained rather than programmed. But we'll discuss this when we cover connectionism. Cheers!